In this video, I'll be walking you through integral problems, integration problems, or problems on integration. Now, this is Further Solutions Academy. Further Solutions Academy. Encourage us more by subscribe, and also share our video. Help us to subscribe and share our video. Once again, Further Solutions Academy. Now, I have a lot of problems here to solve with you. Now, the first one, if I have integral of 2x bracket of x squared plus 4dx. Now, how do I solve this type of problem? What I will just do is what? Let my u equals to x squared plus 4 du equals to 2x dx. My dx equals to du all over 2x. Now, since I have that, I will have what? 2x u du all over 2x. This will cancel this, which I will have integral of u du, which I have u raised to power 2 all over 2. U raised to power 2 all over 2 plus k. What is my u? My u is equals to x squared plus 4 all bracket of all over 2. That is my final answer. Okay, that is my final answer. Another problem. Okay, if I have a problem like this, that I have integral of the x all over x plus 3 all squared. Now, if I should solve this particular problem, I have to go by integral by partial fraction. Now, how do I go? I will resolve this to partial fraction, which to my partial fraction, it will be 1 all over what? X plus 3 all squared. It will also be what? A all over x plus 3 plus b all over x plus 3 all squared. Now, since I have this, I can now say that what? My 1 equals to x bracket of x plus 3 squared plus what? B plus b plus b. Okay, this is going to be, okay, yes. Now, plus b. Since I have that, I will have 1 equals to ax plus, that will be 3a plus b. Now, plus b, my x equals to, my ax equals to 0x, which is my a equals to what? Is 0. Now, my a equals to 0. Since my a is equals to 3a plus b equals to 1, this is equals to 0, it means my b equals to 1. Since I have my b as 1, okay, since I have that, now I can now come back to my problem here, which is my problem is half solved. Now, I can say that my a equals to 0, my b, it means I have this one will become 0 all over x plus 3 plus 1 all over x squared all bracket of what? Of 2. This one has been 0 divided by it will be 0. Now, I can now integrate now. Now, if I should integrate 1 all over x plus 3 all squared dx. Now, it will be what? Now, if I should integrate this type of problem, now I can go by integral by substitute also, which my u, let my u equals to s, my s plus 3. It means my du equals to the x. Now, I can now say that what? Integral 1 all over u raised to power 2 du, it will be equals to, which is I have u minus 1 all over minus 1 plus what? Plus k. Now, u all over minus 1 plus k. What is my u? My u is that, which also implies x plus 3 divided by what? Minus 1 bracket of minus 1. My plus k. My final answer will now be what? My final answer will be minus 1 all over x plus 3 plus k. That is my final answer. That is my final answer. Now, that is my final answer. Okay, that is all for that. Now, another problem. Okay, another problem. Okay, another problem. If I have this type of problem, I have the x all over x squared plus 6x plus 13 integral. Now, if I want to integrate this type of problem, this is very, very logical. I have to go by inverse of 3 if I should achieve this particular problem. Now, how do I go? I can turn this one to what? 1 divided by, out of the, I can say that x squared plus 6x plus 9 plus 4. 9 plus 4. I have the x here. All the x. Now, since I have that kind of, now I'm solving it a bit, I can turn this one to what? If I should factorize this one, I will have something very good. I can say that what? The x all over x plus 3 all squared plus 2 squared, all integral. Now, since I have this, the problem is totally solved. It means my answer will now be what? It will now be, now, sorry, oh, I have 6, I have, what am I doing? Sorry, plus 6. Sorry, this should be plus 6, not plus 4. It should be plus 6. Yes. If I have 13, I have 13 plus 9. I mean plus, okay. 13, yes, sorry. I'm thinking right. Sorry. It will be plus 4. Now, plus 4. Okay, there isn't any problem. Now, since I have this, my final answer will now be what? I have, if I integrate this type of problem, I will be having 1 all over 2, 1 all over 2, which is this 2 here, and I'll have what? Tan inverse of x plus 3, tan inverse of x plus 3, all divided by what? By 2 plus k. That is my final answer. Plus k. That is my final answer. Let me give more examples because this is a bit confusing. Now, let me give another problem. Another problem, if I have integral the x all over x squared plus 4x plus 8. I want to integrate this particular problem. Now, how do I go for this one? It's very, very simple. I can turn this one to what? The x divided by what? X squared plus 4x plus 4 plus 4. Now, this one, if I should factorize this one, I will have dx all over what? I have x plus 2 all squared plus what? Plus 2 squared integral. Now, since I have this plus 2 integral, since I have that, I can now turn it to what? This will be what? 1 all over 2, 1 divided by 2, and tan inverse of x plus 2 divided by 2, all plus what? Plus k. That is my final answer. That is how it always be. Now, in that kind of case. Now, okay, I have another problem that can come out in another way. Integration is very, very wide, but you have to understand it. Now, if I have another problem in this case, now I have integral of e raised to power root of x all over root of x dx. Now, if I should solve this type of problem, it's also very easy. What I will just say, let my u equals to root of what? X. My d, u, it will be 1 all over u, d what? 1 over u, 1 all over 2 root of x dx. Now, okay, since I have that, it means my du is equals to my du, dx, equals to 2 root of x du. Now, put that back here. I can answer that what? Integral of e raised to power u, e raised to power u, e raised to power u, all over what? All over root of x, 2 root of what? X, d what? X. This will cancel this. This will cancel that. Now, I will now have to integral of what? EU du. Now, since I have EU du, which is also equals to what? 2u raised to power plus what? Plus k, which is 2 e raised to power root of x plus k. That is my final answer. Root of x plus k. That is my final answer. Now, that is my final answer. Okay, another problem. Another problem is if I have integral of sine x all divided by root of what? 1 minus x squared dx. I have this type of problem. Now, I can easily solve this particular problem. Hope you know that I can write this as well as 1 all over root of 1 minus x squared sine x inverse into bracket of the x integral. Now, I can easily write that as that. Now, since I have that, I can answer that what? Let my u equals to what? Root of 1 of x. Or let me use my inverse of x. Now, since I have du, it will be what? If I differentiate this, I'll be having what? If I should differentiate this, to differentiate, I can also say that sine u equals to x. Sine u equals to x. Now, I will have what? Du, my sine u equals to x. Now, if I should differentiate this part, I'll be having cos u du equals to sine equals to the hex. Now, equals to the hex. Now, since I have that, now I can now say that what? My ds equals to cos u. It means my dx equals to now at this point I can now substitute for everything I want. Now, what is my hex? My hex equals to, I can say that what? Integral of 1 all over 1 minus, which is sine u all group squared sine u squared. Okay, sine u squared. I can put my u here. Now, also I have, what is my u? I have sine. Okay, this is going to be what? U. This is u. Now, what is my dx? My dx, it will be cos u du. Cos u du. Now, since I have that, I can now easily say that what? Is there anything that can easily cancel out? Now, since recall from trigonometry that my cos u is equals to root of 1 minus sine squared x. Now, it means what? Everything here become what? U. I can answer integral of 1 all over u. 1 all over what? Sorry, cos u cos u du. This will cancel this. Now, left with what? Integral of u. What is my u? This is my u. Now, left with my what? Integral of what? Of u. Now, my integral of u, which is going to be what? Sorry, there is square here. Let me put a square here. If there is no square also, let me put square here. Let me make it a bit out. Now, since I have that, now I can now say that what? U squared d what? Du. which is u squared du. This one will be having squared. Now, since I have that, now I can answer that what? Which also u raised to power 3 all over 3 plus k. What is my u? My u is equals to what? Which is, I have sine inverse of x all over 3 plus k. That's my final answer. That's my final answer. Now, another problem. Another problem is, okay, let me bring another problem that can also be of help in any cases. Now, another problem is, if I have a question like this, I have a problem like this. Okay, I'm to integrate sine square x dx. Now, if I should integrate sine square x dx, I can say that, recall, okay, let me not go like that. Let me put it as sine square 3. Now, if I have something like this, I can say that what? This can also take us to reduction formula. It can take us to reduction formula, which I can say that what? Sine x sine square x dx. Now, since I have this as what? Sine s squared equals to what? 1 minus cos square x. Okay, I can answer that what? Sine x bracket of 1 cos square x dx. Now, I can answer that what? Sine x minus, okay, dx minus integral of what? Sine x cos square x dx. Now, since I have this one will give me cos x. I won't have problem here. I'll be having cos x plus this one the same way. Just put your u as something, and once you differentiate, you will be what? You'll be having my plus, minus will generate here. When minus have here, we'll be having plus. Now, we'll be having plus cos keep x all over 3 plus what? K. Now, that is my final answer. That is my final answer. Now, another problem. Just to solve problem, just to show how problem is being solved. Now, if I have another problem like this, I have another problem in this case. Now, I have integral of x plus 3 all divided by what? X squared plus 4x plus 8 dx. Now, if I should integrate this type of problem, it's very, very technical. Number one, if we differentiate this, I can't have this. There is no possible. Because there is 4. Assuming there is 4 here, there will be a very good. Now, what I will do is that, number one, sure that if we differentiate the denominator, do you understand? If you differentiate the denominator, when you differentiate the denominator, I will have something like this. If I differentiate the denominator, and if I should differentiate this, I will have x 2x plus 4. Now, that is what I'm going to have, 2x plus 4. Now, that 2x plus 4, I will now multiply it. I can use the number of alpha and also add it to what? To beta, which is, I will equate it to what? I will equate it to the what? Numerator, which is s plus 3. Don't forget what I did though. I differentiate this, which I have this particular inside bracket. Now, I will now multiply by alpha and also add the result to what? To beta. Now, since I have that, I will now have what? I will have 2x alpha plus 4 alpha plus beta equals to s plus 3. Now, I will have 2x alpha equals to x. Now, my alpha equals to 1 over 2. My beta, it will be what? 1 over 2, which is I have 3. Okay, let me just do it very well. My beta will be 4 alpha plus beta equals to 3. What is my beta? We have 1 over 2. I have 2. This one will be 2. If I put this here, I have plus beta equals to 3. My beta equals to what? 1. My beta equals to 1. Now, I will now come back to the normal something, which I will have. I can now represent my integral. My integral can now be what? Can now be represented as what? Alpha bracket of 2x plus what? Plus beta, plus beta divided by, which is what? X squared plus 4x plus 8, or bracket of what? The x. Now, since I have this type of problem, I can now what? I can now continue by having, now, what is my alpha? 1 all over 2. I have 1 all over 2, and 2x plus 4, which I can take away this plus 1. Once I have this one can be 2 can move it away, which I will have 1, I will have 2. Now I will have 1, I will have 2 divided by, I will have 1, I will have 2 divided by, okay, I will have this and this, x squared plus 4x plus 8 all integral of. Now, since I have this, now, okay, I don't even need to go like that. Okay, I can now go this way, that this one become a bit simple. I have integral of what? X plus 2 all over x squared plus 4x plus 8 dx plus 1 all over x squared plus 4x plus 8 dx. Now, since I have this, if I differentiate this, I will have this. No, 2, there will be a 2. Okay. So if I have, therefore, let me return my 2 there. Let me return my 2. I have 4. I don't need to change it. Now, because it will cause the problem here, now I have 4. I have 1 all over 2. Now, since I have that, now I can change the what? 1 all over 2. Now, ln x squared plus 4x plus 8 plus, now, integral of 1 all over x squared plus 4x plus 4 dx. Now, 4 plus 4, I can factorize the other side, which I have 1 all over 2 ln x squared plus 4x plus 8 absolute. It's good to put absolute value because there's absolute value there. Now, this one will be what? 1 all over what? X plus 2 plus 2 squared dx. Now, I can answer what? My final answer of 1 all over 2 ln absolute x squared plus 4x plus 8 plus, now, this one, I will be having 1 all over 2 tan inverse of x plus 2 all over 2 plus k. That is my final answer. Now, that is all it's being solved. Now, okay, another problem can also, let me give you another logic behind the integral by parts. I have my reason. After today's video, I'll be working on reduction formula. Therefore, I'm trying to balance so that we have no issue with integration, proper integration. Now, reduction formula is very interesting. Don't miss the video. It's a very interesting part of integration. Now, if I have a problem like, now, integral. If I have, for instance, I have mixture of exponential. I have mixture of exponential raised to power a, and sign is behind of b. I have the c. Now, this is an integral by parts, but it's a very complex integral by parts that you have to go on islet. Now, how do I solve this thing without no problem? I will just solve it this way. It's very simple. The first thing you will do is, I know that whenever I'm differentiating this or I'm integrating, it won't change. I will bring it out and I will write it like this. Now, at the first point, differentiate this particular one. I will have what? I will have a, and I will have sine bx. That is first thing you do. I will have sine b. Now, it will be, when I differentiate this, I will have what? Now, it will be minus minus. Now the next one will be what? E. Now differentiate the argument, which I have B, I will have B, once I have B, cos bx, cos bx. Now divided by b squared plus a squared. That is my final answer. Now let me give another one. If I have integral of e ax cos bx dx. Now I have my instead of giving out when you reach reduction formula, we reach reduction formula, we reach ODE Laplace, you don't have a problem. Now something like that can be given or Fourier series. Now I have particular problem like this. If I have something like this, the same way, e raised to power x integral, which is if I differentiate the first one, I'll be having a cos bx. This one will be. Now, once I differentiate this, I will have cos. I will have minus. That minus will turn it to be plus. Don't forget that uv minus integral of v du is very important. That's what produces this minus here. Now, which I will have plus. Now, plus. Now, I will now differentiate this, which I will have sine. Okay, I will have b sine bx bracket of all over what? B squared plus a squared. That is my final answer. Now, let me use something to illustrate. it. Now, if I have this type of problem, I'm asked to integrate 2x sine 4x dx. 2x sine 4x, or let me use 3. Okay, let me use 3 like x. Now, I want to integrate this thing. The first thing I will do, I will factor out this bracket of. Now, once I have this, differentiate the first one, I will have 3. I will repeat my word, sine 4x plus, okay, that will be minus. Now, minus, I will differentiate this. I will have 4. I'm differentiating this one now. 4. I will have cos 4x bracket of what? Bracket of all divided by, now, which is what? 3 squared plus what? 4 squared. Which I will have 3 squared, 4 squared, 9, 16. Which my final answer will be e raised to power x all over 25. Bracket of what? 3 sine 4x minus 4 cos 4x plus k. That is my final answer. Please, plus k is very important. Plus k is a constant because it's an indefinite integral. Now, that is all about problems on integration. Once again, this is Further Solutions Academy. Further Solutions Academy. Encourage us now by share, and what? Subscribe. Share, subscribe to our channel. You can drop your comments, practice, and anyone you have issue with, drop your comment. We will surely be attended to. Thanks for watching.